everybody, welcome to our last video in Unit 10, all about stoichiometry, which brings us to percent yield. So a lot of times in reactions in chemistry, you're not always going to get the amount of product that your calculations can tell you that you're supposed to produce. A lot of times, all of the time really, you'll produce less than that. And you can calculate how much of that original amount of product you should have produced. And that's called a percent yield. So your percent yield is a comparison of the theoretical yield, which is what you would have found through calculations, doing your mass problems and limiting reagent problems, to the actual yield, which is found through experiments. So you can do a calculation to determine how much product you should produce, and then actually perform the experiment. And you can mathematically relate those to one another and get a percent yield. What percentage of the theoretical amount did you get? And it's quite an easy calculation. So to find your percent yield, it's equal to the actual yield, so what you would have gotten through your experiment, divided by your theoretical yield, multiplied by 100. So it's basically just a percentage. Actual yield over theoretical yield times 100. Let's go ahead and do that last sample problem together in the notes. You will not find this as complicated as limiting and excess reagents. So let's just dive right in, finish this part out.
All right, so the last sample problem of this unit, and I'm gonna leave the equation up here just so we can keep an eye on that as we do this problem. Chlorobenzene is used in the production of many important chemicals such as aspirin, dyes, and disinfectants. One industrial method of preparing chlorobenzene is to react benzene with chlorine, which is represented in the following equation. And just by giving that a glance over, that equation is balanced. So we can move on. When 36.8 grams of benzene, so 36.8 grams of benzene reacts with an excess of chlorine, the actual yield of chlorobenzene is 38.8 grams. What is the percent yield of chlorobenzene? So what this problem is saying is that when you react 36.8 grams of benzene in this, according to this chemical reaction, you are going to actually experimentally produce 38.8 grams. However, that's not the theoretical yield. We could probably produce more than that. And we can determine how much of this chlorobenzene can I theoretically produce based on this 36.8 grams of benzene in my reactants. So we're going to have to do a mass problem here. So let's just set up our arrows here, going from there to there. And that's because if I go back up here, let's use the highlighter, I suppose. We'll use this nice color. So the actual yield is 38.8. I already have this. I have what this chemist produced in an experiment, what was obtained during an experiment. However, we need to find the theoretical yield, what should be produced based on reaction stoichiometry. So let's go ahead and just highlight this in a different color here. This right here is what we're trying to find. So let's go ahead and do a mass problem here. So we have 36.8 grams of benzene. That looks like a funny looking 6, but we're just going to go with it. So 1, I'll fix it, I guess. There you go. Let's use the molar mass first. So grams to moles of benzene, C6H6, grams of C6H6. And the molar mass of benzene is 78.11 grams per 1 mole. That cancels out. Now let's use our mole ratio to go from moles of benzene to moles of chlorobenzene. 1-to-1 mole ratio. 1 mole of benzene produces 1 mole of chlorobenzene. So that cancels. And then let's go ahead and do moles of chlorobenzene. C6H5Cl. And the molar mass of chlorobenzene is 112.56 grams. And when you solve for that, you should get 53.0 grams of this chlorobenzene. This right here is what you theoretically could produce. According to the reaction stoichiometry, you could produce a maximum of 53 grams of this chlorobenzene. However, in this reaction, you're not producing those 53 grams. You're producing 38.8. So we want to know, essentially, what percentage of 53 is 38.8. What's the percentage of that? So to find the percent yield, so we'll just use this equation right up here. It's a really simple calculation, actually. So that your percent yield for a reaction is equal to your actual yield. So that's what this person produced as a result of experiment. So 38.8 grams. And divide that by your theoretical yield. That's what you could produce. And again, you have to find this using the reaction stoichiometry. So that's important there. You can only find that theoretical yield based on a mass-mass problem. And since this is a percent, we'll times that by 100. And when you solve for that, you should get 73.2%. And you don't have to write yield at the end, but I'm going to. So that means that as a result of this reaction, you only produced 73.2% of what you should have produced. And there's nothing wrong with that. Sometimes you might get a very low percent yield, and that's okay. And the next couple of slides here, we're going to talk about reasons why you might not get a 100% yield, because in fact, in chemistry, it's actually very difficult to do that. You're not always going to have it set up this way. Sometimes I might ask you, okay, if a percent yield of a reaction is 80%, how much would a chemist produce given X amount of reactant? So just make sure you can manipulate that equation a little bit, but it's a pretty simple one. Like I said, percent yield is equal to actual over theoretical, and there's those little explanations there. Let's go to the last part in the notes where we talk about why you might not always get a 100% yield.
So now that we've done an example calculation, why doesn't a reaction produce a 100% yield? If you could produce 100% yield, why doesn't that happen? There's actually a plethora of reasons as to why you wouldn't always produce a 100% yield. In fact, chemists might produce hardly any of that. Where does all of that product go? There are two major reasons as to why you won't produce a 100% yield. There is mechanical reasons, which have to do with the nature of the chemicals themselves or the quality of the equipment that you're using, versus chemical reasons. So things that just happen as a result of the reaction that there's nothing anybody could do to really stop it. So some of the mechanical reasons. Your reactants or products may leak out of the reaction vessel, especially if they're gases. If you produce a gas that is a product, it's very hard to contain gases in order to measure how much you produce. So sometimes they might leak out. That could lead to a lower than 100% yield. You didn't do anything wrong. It's just gases, they have all of that translational, vibrational, rotational energy. It's very easy for them to leak out of whatever reaction vessel you're doing them in. Reactants are also not always 100% pure. When I buy chemicals from the science store, I don't buy them pharmaceutical grade. When you have any medicines that are made for you via a pharmaceutical company, they are pharmaceutical grade. They are 100% that chemical compound. That's because you're ingesting that. The chemicals that I buy for our lab, they're not pharmaceutical grade quality. We don't need that super pure reagent for a high school chemistry class. Therefore, you could lose some of your product. You can have a lower percent yield. I don't feel like making the school district pay all of that extra money for pharmaceutical grade. It's silly to do that. It's a lot more expensive to buy 100% pure reactants. I don't do that. There's no reason to do that in a high school chemistry class, but that is another reason as to why we won't have a 100% yield all the time. And some of your product is lost when it's purified. That's not something we necessarily do, but in many lab situations, you might need to purify your final product. And sometimes you can lose some of your final product as a result of doing that. If you are in the pharmaceutical business, you want to make sure your final product is pure. And you'll have to do a couple of extra steps to do that, and you might lose some of that product along the way. There might also be just chemical reasons as to why you're not producing a 100% yield. Sometimes the products decompose back into the original reactants. If you decide to take AP chemistry, you'll learn all about equilibrium. And a lot of reactions don't just produce the products and that's it. Sometimes those products can decompose back into the original reactants, and that could lead to a less than 100% yield. Your products could also react together to form something totally different. I get it. It just happens. It's not your fault. It's not my fault. It's not anybody's fault. It just happens. You could form something else. Some of the reactants could react in a way that's not represented in the equation or in your reaction, and that's called a side reaction. Sometimes your reaction might react with, or sometimes your product might react with oxygen in the air. And that's a side reaction. You're not going to produce a 100% yield if your final product reacts with oxygen. And lastly, the reaction occurs very slowly. Something else you'll learn about if you decide to take AP chemistry is all about reaction kinetics, or how fast reactions happen. A lot of times reactions don't just happen and that's it. They might react very, very, very slowly. And if you don't wait long enough, you might not get a 100% yield. You might get quite a bit less than that, depending on how fast the reaction is. So, of course, percent yield is crucial for chemists everywhere that are in the field. They're concerned with the yields of reactions, of course, because not only do they want to carry out reactions that don't waste a lot of money, but they also need to produce a lot of something. If the yield of a reaction is too small, the product may not be competitive in the marketplace. So if you are a chemist and you are trying to produce this new this new compound that cures cancer, but you only have a 5% yield, it's not going to be very competitive. You're going to be using far too much money in order to produce something that's only a 5% yield. Chemists want to increase their yield. So they do that by altering the reaction in numerous different ways, which I'm not going to get into here. So of course, if a reaction only has a 50% yield, it produces only 50% of the product it should. If you have a 5% yield, you're losing 95% of that product along the way. You want to always increase your yield. You want a 100% yield. I hope that helped. This, like I said, is not a very complex topic. It's very easy. Percent yield is just determining what percentage of the final product did you produce compared to your mass stoichiometric calculations. If you have any questions, let me know. Stop in and see me before or after school, during lunch, whatever works for you. Otherwise, I will see you in the next unit, which is all about gas laws. So have a wonderful day, and I'll see you soon. Bye.